Solving trig functions with trig identities. We will be using the reciprocal and Pythagorean identities to solve for our functions. Just know that, again, we're over the interval of 0 to 2 pi if we want to write it in inequality. And I want you to kind of get used to this because we're going to use it when we talk about double angles and half angles. So 0 is less than or equal to x, which is less than 2 pi. Again, 2 pi is not part of the domain so we can't have that in our answer. Okay, so let's look at number 1. Sine squared x times cotangent x equals cosine x. So try and get these identities as much as possible to maybe one like sine or cosine or something of that effect. That mostly sine and cosine is best for us because we know exactly what they are when it comes to looking at the unit circle to find those exact values for us. So I'm going to take this and I'm going to just change cotangent x. First, I'm going to rewrite sine squared x. And I'll change cotangent to its. So it's cosine x over sine x. And we still have this over here on the right. It hasn't changed. So cancel when you can. So reduce our fractions. So this is going to reduce with 1. And this leaves us the sine x. So let's clean this up. Okay, so now that we have sine x equals cosine x, next step is to move everything to one side by setting equal to 0 and then solve. So let's move the cosine x over to subtract it from both sides. Now these are not like terms, so it should look like this. Cosine x, sine x times cosine x minus cosine x equals 0. Now at this point, you are in less than 9.3. I mean, yeah, 9.3. Okay, and this is the factoring part. So we're factoring. We have, if we look at two terms, what do they have in common? The GCF is cosine x. So let's just factor that out. Remember, if you need to, divide it out so you can see what you actually have, so that make sure you don't make any mistakes. So this equals sine x minus cosine over cosine is 1 equals 0. All right, so now let's set these angles equal to 0. Again, still in lesson 9.3, so the only thing new that we're adding to this lesson is just using our identities. And now this part right here is lesson 9.1. So where is cosine x equals 0? At what angle does that happen? So you're looking at your unit circle. Okay, where is cosine 0? It's on the axis, the quadrantal angles. Okay, so that's at x equals pi over 2 and 3 pi over 2. So this other side, we're going to set it equal to, solve for sine x, excuse me. Sorry, I said equal to 0. And then, so now we're at sine x equals 1. So where is that angle where sine x equal, when we take sine of it, it's equal to 1? Well, that is also at pi over 2. Okay, don't need to do this one because it's repeating over here. And so these two are your solutions. Okay, number 2. Now, number 2, if you notice, we have a sine squared and a cosine, and then we have a 3. So this is 3 terms. So we have a trinomial. So when you have that trinomial, you need to be in terms of a function. So this needs to be in terms of a function for trinomial factoring. I have 3 terms. That's what I need to do. So the first thing I'm going to do is I'm going to try and make it to where I can be in that, the same terms of the function. So if you look at these two, you have here a cosine x, and then here a sine squared x, okay? I mean, cosine x you can't really change to. We're not changing to a reciprocal of any sort because that's not going to help us to solve. So what we want to think about is how can I change maybe this sine squared in terms of cosine x? And I'm not saying it's going to always be right away you got it, but just do enough practice of them. Just know that, okay, if I have these two or three terms, I'm probably going to have to do, I will have to do a trial and error factoring of a trinomial. So I want to make sure that I have it in some kind of quadratic form that I'm able to factor. So what I'm going to do is I'm going to change 2 sine squared x to its identity. Okay, so this is going to be 2. And then sine squared x identity is 1 minus cosine squared x. Okay. And on the other side, we'll just rewrite what we had up there. Now I see that square over here, and then I see this x here. So the best thing to do is to FOIL and then move everything to one side. And we're just going to rewrite this. These are not going to like terms. So that's 2 minus 2 cosine squared x. Now let's move everything to the left. The reason I'm doing that is because we have a negative here and I want to make that positive. Okay, so I'm just going to go little by little, make sure we're okay. 3 minus 2 is 1. And then usually when we write this, we're going to think of something as 2x squared minus 3x plus 1, kind of like, so see that it looks something to that effect. So I'm going to move this cosine over. It's going to be a positive now. So 2 cosine squared x. I'm going to do the minus 3 cosine x first. And plus 1 equals 0. Remember, we can rewrite and rearrange addition and multiplication because it's commutative, but make sure that you keep the sign with the that term. So we're going to factor. So we know 2 cosine x. 2 is the only factors 2 and 1 of 2, so this just has to be a cosine x here. 1 only has factors of 1 and 1. And we know if there's a minus and a plus, this has to be a minus and a minus. Oops, so there's 0. Should be equal to 0. Okay, so now we're up to, again, this is lesson 9.3. So we set things equal to 0. Each factor is set equal to 0. And then we're going to solve. And then this is lesson 9.1. So everything we've done so far in this unit just keeps coming back and being used again. Solve for cosine x. Okay, so I'm going to look at the one on this here first. So again, so where is cosine equal to 1? So what's that reference angle? What's x equal to? And I get a 1. And again, that's only can be on the axis, the quadrantal angles, the 0, pi over 2, pi, 3 pi over 2. They're not in a specific quadrant because it doesn't lie between it. It lies on an axis. So that value is only 0. And then let's look at the other one. The other one we're going to talk about, let's talk about the reference angle and so forth. So I need to find out where cosine is equal to positive 1/2. So I'm going to do it here. So it's positive, cosine is positive in quadrant 1 and quadrant 4. Okay. So where is that angle at? What's the reference angle? Okay, so where's that 1/2? And that would be at pi over 3. Okay, so the first quadrant, it has to be pi over 3 because the reference angle is in the first quadrant. And then the fourth quadrant, we're going to take the denominator, 3 times 2, that's 6. 6 minus 1 is 5 pi over 3. Now, one thing that I didn't think about when I mentioned classes, make sure that you checked, are all these answers within the domain? So in other words, are they less than 2 pi? And they are so far what we've been doing. So x equals pi over 3, 5 pi over 3, and then we have 0. You don't have to do them in this as long as you just box in what your answers are, but I just kind of make it easier to see. Example 3. Okay, again, you're going to use our identities. I'm going to change cosecant to 1 over sine. And secant is 1 over cosine. Since we're dividing fractions, we could say that it's 1/2, 1 over sine x times, and we take the reciprocal and multiply it by the reciprocal, which is cosine over 1. So this really gives me cosine x over sine x, which is the same as cotangent x. Okay. So we have cotangent x equals 3. And I'm going to get rid of these equals right here. So what we're dealing with is, what can we do here? Okay, so before we get started, we don't really use cotangent. And we do have a chart. You could memorize them, but most people don't. But remember, cotangent is the reciprocal of tangent. So I'm going to take this step to make sure that everybody understands how we do this. So we know that this can be changed to 1 over tangent. But I just want tangent to be not a denominator. So remember, mathematics-wise, what you do is one side to the other. So if I flip one side, I have to flip the other, okay? So pretty much we just took the reciprocal again of that. But we're not going and changing it to finding the reciprocal. We're changing it by taking the reciprocal, just like we decide maybe to multiply 3 to both sides or divide both sides by 2. So this is going to be under here, okay? So 1 over the square root of 3. So what are the values or the angles? Remember, you're always looking for angles here. That of tangent x that gives us 1 over the square root of 3. Okay. So the first thing you want to think about, it's positive. So tangent is positive in quadrant 1 and quadrant 3. So what's the reference angle? So if we think about what is happening, and we've discussed this in several of our other lessons, is that when we want to identify how we find tangent, tangent is always sine x over cosine x. So what happens is we want to put this together. So obviously these x's are the same. So we think of our reference angles at pi over 3, pi over 6, pi over 4. Well, it's not pi over 4 because that's square root 2 over 2. So what I do is to kind of like to help me out is that if I have a square root of 3 down here, that means I have to have the square root of 3 on the bottom. So in other words, I have the point square root of 3 over 2 and 1/2. Those are our points that we use between 30 and 60. These two here, square root of 3 over 2 and 1/2. So those two values are the points that creates a point. Those are the points that we use to find, using those reference angles, how do we find those points on the graph? And that's what we're looking for. We're given the point part, and we want the angle. So we have to think about cosine. Remember, this is x, this is y. So that means cosine has to be square root of 3 over 2. And the reason we think about that. And then the biggest thing is you're not too sure looking at it, then just test it. Okay. I know here if I do 1/2 divided by square root of 3 over 2 because it's sine over cosine, then that means if I were to simplify this, 1/2 times 2 times the square root of 3, cancel, cancel, 1 over the square root of 3. So this is the way that we want it to look. We want sine to equal 1/2, cosine to equal square root of 3 over 2. So we have to ask ourselves, what reference angle, at what reference angle will sine give us a 1 over square root, or excuse me, a tangent give us a 1 over square root of 3? Or even go back to, even going back to just looking at sine x. Where is sine x equal, where I get a 1/2? And that reference angle is always pi over 6, okay? So we are positive in these two quadrants that we have here, but we are also, reference angle is going to be at pi over 6. So because we're in quadrant 1, pi over 6 is an answer. Quadrant 3 is always going to be numerator 1 greater than denominator, 7 pi over 6. And that's what x equals to. Okay, last problem. So again, changing everything to something of an identity or reciprocal function so that we can reduce. Okay, so secant is the same as 1 over cosine x. Multiplied by cotangent, which is cosine x divided by sine x. And then lastly is cosecant x, which is 1 over sine x. That equals 2. So cancel what you can. So this cosine x goes 1, this goes there. Nothing else is able to be canceled, so I multiply across the top, 1 times 1 times 1, the numerators. And then on the bottom, 1 times sine is sine squared x equals 2. Okay. Okay, so let's see. I only have one term over here. So first thing I'm going to do is I'm just going to get rid of the fraction. Okay, so I have 1 over sine squared x equals 2. If I rewrote it as a reciprocal, it'd be cosecant squared x equals 2. At this point, we don't necessarily have to do that, but I'm going to do it. I'm just going to think of it. I can just verbally say it, but this is the same thing. And the reason I want to write this is because sometimes people see things differently. And so if I just take this on the left, this one here, and I just flipped to make this in the denominator, that means 2 over 1 flips, it becomes 1 over 2. Well, the other thing about using your identity, and that was the whole idea of this thing, of this topic, of this lesson, is that this becomes cosecant squared x. And then to take the reciprocal of that, it's sine squared x equals 1/2. And I just didn't show my extra step I did earlier. So either way, it's fine. You're getting the same answer. You notice they look the same, okay? So just know that they're just like two different ways people see it. Depends on how you do it. If we're using all our identities all the time. We used our identities up here to help us to cancel, so I'm okay with that as well. So as long as you're doing your legal math and you're doing rules that you're allowed to do in mathematics, then it shouldn't be incorrect. The idea was I have a reciprocal. I need to get this fraction, the sine x out of the denominator, no longer be a fraction. So I flip both sides, which is taking the reciprocal. And then now we're going to solve for x. Okay, so if we have a square, then we need to make sure that we take the square root of both sides. I'm going to leave 1/2 on that side because if we had x squared equals 1/2, we would leave it right there and take the square root of both sides. So we don't need to move it. So let's still take the square root of both sides. And by the way, both ways would be worked this way. So this way I'm just going to stop here and I'll do the work over here. So we get sine x equals, now again, we talked about this in 9.3, that if you introduce a radical, a square root, then you need to add a plus or minus. Because remember, square root of something is plus or minus the square root of 1/2. So I'm just going to take a few longer steps to make sure we understand. So this is now the same as plus or minus square root of 1 over square root of 2. Well, I know the square root of 1 over square root of 2, I get 1 over square root of 2. Now, you can leave it like this because what I want you to think about, there's only one way to get a square root of 2. There's only one reference angle that has a square root of 2 in it. But I want you to see also well that we also rationalize this denominator. So we'll rationalize it up here. So we rationalize it, we get square root of 2 over 2. And we did this in our last lesson as well. If you rationalize it, then that looks familiar. Okay, square root of 2 over 2. Either way is fine, as long as you understand. Remember that anything with the square root of 2 over 2 is always going to be your reference angle of pi over 4. Okay, so now we got to figure out now, sine is positive and negative. That's what we want. So that's all 4 quadrants. Okay, so we're going to start with quadrant 1, 2, 3, 4. All of these are your possible answers or your answers. So sine pi over 4 is your reference angle in the first quadrant. The second quadrant, it's going to be numerator is 1 less than denominator. So it's 3 pi over 4, then 5 pi over 4, and then 7 pi over 4. Like I said before, I just love trig and all the different nice little tricks it has and patterns. So if this is 1, 2, there's each of these, it's got an odd number. Of course, obviously the 1's not here, but if we wrote it, it'd still be the same thing. So all 4 of these is the solution. And again, thinking about ahead, we just want to ask ourselves, are they all less than 2 pi? And they all are. Okay, so real quick before we're finished, I want to kind of discuss and kind of review reciprocals, okay, of a 0 and undefined. If I have 0 over 1, and I say the reciprocal of that is 1 over 0, but this is undefined. Okay, so you can still take the reciprocal of 0 over 1, but you're going to get an undefined answer. And you can do vice versa. If I say I have 1 over 0, and I take the reciprocal of it, just because it's undefined here, doesn't mean it's going to be undefined when you take the reciprocal. Because remember, the reciprocal is flipping it over. Well, the 0 is no longer on the bottom. So this is the reciprocal now. So this is actually equal to 0. So remember, this equals 0, and this equals undefined. So to know that you can do that. And the reason I talk about that is when we talk about certain problems when we have a secant or cosecant. So with that said, I'm going to do a problem with you really quick to make sure that you keep that in mind. And since I've already gone over this part of the problem, let me go back here and I'll just erase this. Okay, so let's think of problem like this. So if, let's say we have tangent squared x minus secant x equals -1. Move everything over to the other side. And then we get, well, let me change this first into terms of secant. Okay. So the identity of the tan squared x is equal to secant squared x minus 1 minus secant x equals -1. So when I add 1 to here, I wind up getting secant squared x cancel minus secant x equals 0. 2 terms. Now I'm going to pull out the GCF. Our GCF, greatest common factor, is secant x. So we're going to factor out secant x. So I'm going to take out secant x, which leaves us with a secant x minus 1. Set both of those equal to 0. So I'm going to look at this right side. I believe this is like number 3 from your homework. But I'm going to work with this one right here on the left. I mean on the right. So if I set this equal to, solve for secant x, I'll move the 1 over and I get this. And so what is the reciprocal of secant x? That's cosine x. And cosine x, I just flip it over, I get 1. So the only value where cosine x can get a 1 on the graph is at x equals 0. So on the other side, we set secant x equals 0. And then what we try to do here is that when we take, and I'm going to go through the step by step so that you see where I'm getting this actual answer. Oops, didn't mean to erase all that. So secant, oh man. So secant x equals 0. This would be 1 over cosine x equals 0. And then what I want to do is reflip it. So if I put this over 1, I flip it, and I get cosecant x equals 1, 0 over, it's going to be 1 over 0, and that's undefined. So this will never happen. So this will never be part of it. And so your only answer is x equals 0. So pay attention to those reciprocals of zeros.